Welcome to the Circuit Cellar Podcast.
Inspiring the evolution of embedded design since 1988.
We are thrilled to have as our guest today Fernando Valera, who is the CTO at Visure.
Thank you for having me. It's a pleasure.
Fernando, we're going to be talking about safety critical systems. And as we're beginning, could I ask you to introduce yourself to our listeners?
Absolutely. So my name is Fernando Valera. I'm CTO at Visure Solutions. And I've been in the field for more than 25 years and specialized in requirements engineering, deploying our own product. Visure is the name of the product, and also requirements engineering processes. I started off in Europe. I did that for a decade, and then I moved on to the Americas. And I managed to get a little bit of insight on how different regions in the world deploy requirements engineering processes worldwide. Very interesting. And we've been able to bring all this knowledge into our platform.
Mm-hmm. Outstanding. Well, some of those things we're going to be digging into in some detail. So let's get to it. We were talking about safety critical systems. And first, let's define some terms. What is a safety critical system?
Mm-hmm. Yep. So safety critical system is a system where human lives depend on. So if something breaks or doesn't work as expected, then someone's life could be lost. That's like a very layman terms definition.
Okay, because I know that a lot of people would ask how that differs in terms of design principles and design philosophy from a critical system, critical infrastructure.
Mm-hmm.
Is there overlap there in how the systems are approached?
Mm-hmm. So I would say that at the beginning, it was all the same. And when we started introducing, let's say, software in the brakes of the car, the way in which software was developed was pretty much the same as any other software. So it was only when, given failures made it to the news, then it started to be considered as safety critical. And safety critical means not only just the categorization as such, but also the fact that it's regulated. So every step of the way has to follow a given standard. So you just cannot release the software without getting a certification or being reviewed by somebody and so on. So I think nowadays, we can differentiate safety critical in different industries. Like aerospace is the I would say the most regulated environment, followed by automotive and medical devices, and then other areas like nuclear are regulated, but not as thoroughly as aerospace, right?
It's interesting that you mentioned aerospace. I live about 30 miles from Cape Canaveral.
Uh-huh.
And the NASA human carrying missions are sort of famous for the software requirements and the attestations that programming managers had to make before software could fly. Basically, they had to attest that their software would do nothing to endanger human life. And that's an interesting level of certification required. With the certification set aside, let's pretend that we're all just designing this to be as safe as possible because we know it's the right thing to do. Are there special considerations or design philosophies or workflows that are used in these safety critical systems as they're developed that might not be used in normal, put that in bunny ears, normal operational technology embedded systems design.
Definitely. And from the ALM perspective and from the requirements management perspective, which is and especially in highly regulated environments, which is our specialization, one of the areas that are fundamental is just the activity of sitting down at least and think of what could go wrong, like risk management and considering, as you mentioned, software cannot put human lives in danger. So considering that software is going to fail and the probability of it failing is going to be close to 100%, if not 100%, what are we going to do at that point when it fails? Are we going to have redundancy? So, but for the rest of the areas, same thing. Coming up with safety requirements from the beginning that will actually drive the design is going to be fundamental, right? And so many other areas like in the verification aspects, making sure that we're more thorough with any activity and action that is going to be safety related, is going to be extraordinarily important.
Well, with safety as a consideration, it seems to me that no matter what the embedded system is, whether it's something that's a home control, environmental control, or something on a shop floor or a building environmental control, that safety should be part of it. You don't want a system to fail in a way that would be dangerous. And so are the differences in the way that safety critical systems are designed and considered in the design, are these things that most systems should take into consideration during their design, or are there reasons why the safety critical systems are special and contain, principles that shouldn't be considered in other less critical systems?
So, it depends on the environment that we're working on, but definitely there are design principles that we have to take into account when working with embedded environments, or embedded systems. The way in which the systems are designed from the requirements perspective, right, and that flows into the design, right. We specifically work in a specific with specific teams from the different environments, and we have to consider the system as a whole, right? Not only the software as an isolated piece, right? But also when we have the software and the hardware and the mechanical pieces, right? So the software is going to be embedded on a target environment, and that the software could work perfectly on its own, but then when we embed it into the target, that's going to be a completely different universe. So the being able to design it accordingly to the rest of the system is going to be fundamental. The interfaces to the rest of the to the system has been traditionally one of the weakest points, right? So what we're trying to do from Visual's perspective is that we try to break those silos of the software considered as a software discipline, hardware as its own discipline, and so on. We've seen that integrating the teams right from the beginning, being able to define the system as a whole, bringing systems engineering. Now it's very common to hear the term of model-based systems engineering as a way of breaking those silos and start thinking about safety directly from the system perspective without having to wait until the design, right? And working with the software team as an integrated piece of the system has proved as a fundamental part of the safety, working from a holistic approach, right?
Mm-hmm. Well, I want to get into some of that. But before I move on, though, you used a term early on that some of our listeners might not know, and that is ALM. Can you quickly define ALM for our listeners?
Yeah, absolutely. And thanks for bringing that up. So ALM stands for Application Lifecycle Management. The ALM has been traditionally in charge of all the activities that have to do with software development. So opposed to another term that listeners might be more familiar with, like PLM, Product Lifecycle Management. And ALM it's a little bit foggy because every organization has a different kind of idea of that could mean. Whereas PLM, it's pretty clear. We have the BOM and the 3D and the CAD and so on and so on. But nowadays, all those lines are getting blurred out, and the reason is that everything is digital now. And we see that software has been iterating very fast, but hardware development and also, all disciplines are basically faster now. They are extraordinarily faster. And the cadence of hardware and software need to be in sync. So PLM, or the product development with the software development, has to go hand in hand. So we have to make sure that whatever platforms are being used by those teams, they can work together. So if the hardware team needs to change something, the software team will be aware of that, and the other way around. And going back to the certification, obviously indicates that all that has to be done, but sometimes it's not absolutely clear how we're going to do that, right? And it's up to each organization to figure it out to a certain extent, right? So we're trying to bring some knowledge to our customers, showing them, it's like, hey, this is how we should integrate all these parts. Try to do all the thinking at the beginning, all the systems thinking. Think about this as a whole, not just bits and pieces that we put together and then magically works, and so on, right?
It's interesting because you talked about every organization does it differently. Mm-hmm. Not surprising to hear that. Mm-hmm. But having said that, are there accepted best practices? Have any organizations, whether it's NIST in the U.S. or any of one of the European agencies, come out with a suggested best practices for designing with safety in mind in order to meet whatever this individual certification might be?
So yes, there are organizations that provide best practices. And you mentioned NIST. For instance, it's we hear a lot of zero trust architectures, those sort of things. Our customers working on aerospace, automotive, and so on, they are very conservative and traditional. They usually have kind of their own internal guidelines that they follow, pretty much like the Bible. And then for smaller organizations, what we see is that they do make use of standards, best practices. What we see is that they rely a lot on vendors to bring them those best practices. But now what we're seeing is that they are relying a lot on AI to even propose those best practices, right? And we see two absolutely different rhythms. Or three, I would say three. We have like the very traditional organizations that are very slowly adopting AI. And it's very related to the size of the organization. The bigger the organization, obviously the harder it is to implement something so disruptive. And then we see the other extreme, which are the smallest organizations that are implementing everything through AI, even, as I mentioned, best practices with no control and relying 100% on that. And then we see the organizations that are using AI as a tool. And they are obviously automating actions. For instance, they might ask, like, hey, implement this design best practices in the modeling of this 3D piece, or of this electronic component, or even the software. But there's always a human in the loop, double checking that it has been implemented appropriately, that the best practices were implemented by design, not just brought up, and God knows if they are complete or not, right?
One of the things that I have been covering for years, pardon me, is security.
Mm-hmm.
And in the security realm, tools like the bill of materials, the SBOM, software bill of materials, all of these are critical because of third-party risk. In other words, not simply how safe is the system that I'm designing, but how safe are each of the components of the system as I'm putting them into the final design.
Mm-hmm.
And that's now accepted practice in security. Is the same thing true from a safety standpoint? Do teams that are designing systems have to look at the inherent safety of the components that they're using in order to figure out how safe the final system is going to be?
Mm-hmm. And so I think there are two very interesting domains. One of them is how safe, and the other one, how secure the system is going to be, right? So, for instance, now we have the upcoming CRA, the Cybersecurity Resilience Act, that everybody will have to adapt to in the European Union. But I think this is an evolving and a very interesting area. And the reason is that we have been focusing on making a system safe and design principles. But we have been focusing on what happens, let's say, unintentional risks, right? So, ISO 26262 in automotive would say, yeah, well, what happens if this component doesn't work as expected, right? So now every industry released their own security area or standard for intentional risks, because we see that cybersecurity is becoming, extraordinarily important, and now with Mythos or Fable or whatever the latest models, now we're starting to doubt whether that task of making the system secure can even be done by a human, right? Like we can make a system safe. Can we make it secure as a human, or will I need to absolutely use AI to find all the gaps that I might be missing, right?
It is interesting. As a human being myself, I would love to think that that we can handle this. But as you point out, using AI as a tool, the proper use of AI, I think is going to be very helpful. The tricky part is that phrase, proper use of AI, because I suspect that in this evolution, we're going to see some unfortunate over-reliance on AI in some instances before we finally figure out what the overall best practice is.
Yeah, I think as humans, also as a human myself, we follow a pendulum type of psychology. We have to go to one extreme and then go to the other extreme to actually find the limits and figure out what the middle term is. But I already see an extraordinary over-reliance on AI from some organizations that even makes me a little bit nervous. It's like I wouldn't I wouldn't be able to sleep like this, right? But we have our office in San Francisco, right? And we are already seeing it in some tech companies. Tech companies, they can innovate, incorporate new technologies as fast as they want or they can, opposed to safety critical organization. And we see that they have, we've seen massive layoffs by all the big companies, and we're already seeing some companies laying off their AI, meaning that they are going back to just dropping some AI and hiring back some of the humans because they had some knowledge that the AI didn't have. They just thought that something that responds in a reasonable way is completely intelligent, but they found out that, actually not, right? Surprise.
I'm shocked, I tell you. Well, Fernando, we're coming down towards the end of our time together, and there are a couple of things I want to make sure I hit. The first is this: if someone is beginning the process of designing for a secure, safe system, an inherently safe system, how should they begin? What should they begin to do to launch them down this path toward being able to design a system that might ultimately meet certification requirements?
Yep. So, and again, from our perspective and our expertise, which is ALM and requirements management, the majority of the standards out there, if you look at ISO 26262 or IEC 62304, DO 178, one of the first things is like, just write down the intended intended function of the system, right? So making sure that you are able to describe what the system shall do, right? Making sure that you write all the requirements of the system. That's one of the first, most fundamental parts. Why? Because that is going to be what will determine what a safe design is, in the sense that you first need to know what the system is intended to do, right? And what's intended to not do. And then once you describe what the system is intended to do, then you can come up with, okay, so what would happen if this function was not accomplished, or what would happen if this? What are the gaps that we have in here? What have we not taken into account? And then once you have completed all that, then you can start with a safe design. It's following some of the design principles that we would like to include, right?
Outstanding. Thank you so much for that. And the last question, I suppose, is if someone wants to know more about Visure and begin the process of deciding whether it is a tool that they can incorporate into their workflow, how would they get started there? What's the best way to begin that process?
Yeah, so visit us at visuresolutions.com. They can get in contact through the website or info@visuresolutions.com. Depending on in the industry, automotive, aerospace, medical devices, nuclear energy, whatever, we would be more than willing to set up a session where we can guide them through the platform, the standards, how it can help them, and take it from there. Mm-hmm.
Very good. Well, Fernando, thank you so much for being with us today. I truly appreciate it, and I will look forward to having a chance to have another conversation with you down the line, because I think there are still a lot of things that we could profitably spend some time discussing here on the Circuit Cellar Podcast.
Learn more at circuitcellar.com.